This is an important video for you because one day somebody's going to say, oh, logarithms, oh, I hated logarithms. Logarithms stink. And you have two choices. You could say, yeah, you're right. Or you could say, no, enough is enough. I like logarithms. Logarithms are cool. I get them. The choice is yours. So, awkward transition. Logarithms are just another way to think about exponentials. And you've dealt with exponentials, right? If we had 3 squared, we know that that equals 9. If we're rewriting this as a logarithm, what we do is we'd go ahead and say log base 3, this base is important, 9 equals 2. So you can see we have the same numbers here. 3 squared equals 9. 3, 2, 9. But we rewrite it saying log base 3, 9 equals 2. So just to visualize really quickly the difference between an exponential and a logarithm, we've learned that an exponential gets really big really fast. If we had a graph here, it would start small and then quickly shoot up into the infinite skies. A logarithm will get really big, but much more slowly. It'll actually look like this-ish. See, it's still going up, but much slower. And we could see from our example earlier that when we had 3 squared, we get 9, a fairly large number in comparison. But when we take the same 3 numbers and rewrite them in logarithmic form, we only end up with a 2. That's contrasting 9 and 2, much smaller, written as a logarithm. This is useful in the world, in computer science and population growth models, anything that takes very large numbers and wants to condense those into more manageable components. Here we'll quickly summarize what you need to know for logarithms this lesson. If you had log with a base of b, a equal to c, we can transition that to b, that's your base, to the c power, what it equaled before, is equal to a. And before doing some examples, a good little thing to note is that if a log is missing a base, if you do not have a base written for you, you can automatically assume that the base is 10. So if there's no base written, the base is automatically, the people who decide things in math have decided that the base will automatically be 10. Okay, a few quick examples and we'll call it a day. Here we just want to solve for x using what we know about logarithms. Here we go. First off, log base 2 x equals 3. So we just want to take our base here, which is 2. We set it to the power of what we're equal, which is 3. And that's going to equal this guy right in here, which in this case is x. So x equals 2 to the third power, which is 2 times 2 times 2, which is 2, 4 times 2 is 8. So in this case, x equals 8. Moving on. Whoop. Here we've got log base x, 16 equals 2. Same thing, let's take our base, that's x, to the power of what we're equal, that's x squared, equals 16. Alright, so think about this for a second. What squared equals 16? Well, I know that 4 squared equals 16, so I can go ahead and say x equals 4. Moving on. Log base 5, 125 equals x. Let's take that base, 5, to the x power equals whatever our log is right here of 125. 125. Okay, 5 to what power, x, equals 125? Well, 5 times 5 is 25, times 5 is 125. So x is going to equal 3. We know that because 5 to the third power equals 125. Last but not least, log 1000 equals x. Uh-oh, no base. What do I do here? That's right. If you don't have a base, it's automatically 10. So I'm going to write that in there. Then we're going to take our base, set it to this exponent. That's going to be 10 to the x equals, that's base 10 to the x power, equals 1000. 3 zeros. Now 10 to what power equals 1000? 10 times 10 is 100. Times 10 is 1,000. Perfect. So x is going to equal 3. That's 10 to the third equals 1,000. X equals 3.